Kubernetes, now this was created by Google, and it was then eventually published to the community. And AWS has its own flavor of Kubernetes, as do other organizations. Azure Kubernetes service, Google has its own as well, which is Google Kubernetes engine. But Kubernetes, EKS, delivers a fully managed Kubernetes service that combines the power of Kubernetes with AWS's scalability. Few of the features that EKS provides is easy cluster management. It simplifies the cluster creation, scaling, and maintenance. Like ECS, this also provides a lot better integration with AWS native services, such as elastic load balancing, IAM, and more any like SQS if you require. You could also have seamless integration with Kubernetes environment. Now this is the EKS. It again adheres to the industry standard. It tries to keep up with the industry standards that are there, the pace that is there, and so you will see the latest and greatest versions of Amazon does manage as well. So something to look into. Now the next one is compatibility with Kubernetes tools. Now this is where, it harnesses the power of open source container orchestration, and along with it, there are a lot of tools that the community has that EKS, it provides. That is, it has access to the extensive ecosystem. It provides cluster autoscaling. A few of the tools that are there, like kubectl, is there. It's supported by Kubernetes. You have autoscaling as part of the setup as well. And that's based on the workload demands. You have RBAC policies, role-based access control policies, that provide fine-grained control over access and permissions through roles. And this is where Kubernetes provides a lot of these tools that are supported as part of the EKS. And likewise, going to the console to show here. Now, let me come back to the ECS. This is where I was seeing that. Please try again for ECS. If I have to redo this. Now, so moving to Kubernetes, I'll just go here. If I search for EKS, I will be seeing this in the drop down, and I can click on it. And yeah. So now Kubernetes, it's a little more complex compared to ECS, which has a cluster. Could have the services created along with tasks created. But with Kubernetes, it's a lot more tools that need to go in. And just to show the process I had to go through, I have done this setup because if I had to do this right now, it would have taken me a long time. So just to show you all, this is the setup I had to do. And it took around 30 minutes let me try expanding, where what I had done was I ran these commands. That is, I had to first install kubectl, and that is where I set it up. I had to provide the permissions to kubectl, create the required directory, and then provide EKS kettle as well. I wanted to download it. It's a little bit more options compared to kubectl. This is where my token, SSS token, I had to provide so that I'm able to use kubectl. And this is using the EKS kettle, I'm able to create the cluster. This is what I used as part of the creating cluster. And now we could see this is the cluster it created. And so let me quickly show you the setup for the cluster. So this is the EKS cluster that is created. Now we can see the GUI. This is the new GUI compared to the older GUI that is there. This provides you a lot more option over here. Now in EKS, we see that this is the API server endpoint, and this is the OpenID server endpoint. The role that is required for ECS is kind of mandatory to have this ECS setup, while EKS setup. While in ECS we saw that we didn't have to create a role. All we had to do was provide just a cluster. And in this cluster, we're going to create the services and the tasks. Now, this is where I'll show you the comparison. But again, coming to EKS here, I could have all these setup done. And now these are the resources. You see there are lots of resources here that are there in Kubernetes, which again gives the impression of it being a lot more complex compared to ECS, which if you see here, we could create a service out here. I could create a service. I could say this is a capacity provider strategy, something that is recommended to use And that's where we could get into the next topic, that rather than launch type, this is recommended. We could choose the capacity provider. What is the algorithm? And each service, it can have a separate capacity provider attached, or we could have multiple services using one capacity provider as well. So that is the fundamentals that we educate a customer, that when to use which scenario. In case you want to do isolation, or if you want to use resource optimization, we are better off using one capacity provider for multiple services. And this is the application deployment configuration, application type service versus task. Now, we have seen both scenarios where, like, we at Arina Technologies, we recommend customers to use a service where we think that this is the better pattern. This is the ideal pattern to use specifically for microservices architecture. And what we have also seen is customers directly using a task as part of the cluster, which we think is an anti-pattern, which is something that we shouldn't be done. Now, but AWS does provide an option for scenarios of that. But for the purpose of this, let's choose a service here. You could provide the task revision. And I don't have any task definition. Task definition is something I will be creating if I am able to set it up. But let me just show you how I can go about creating a task definition. So if I have to choose it, I could create a new task definition and I could give it a name. All right. Task def example. And I could choose ECS target or over here. And this is where I'll be able to choose the architecture, the memory, the role I'll have to create, and then accordingly create a new role. And this is where I'll be choosing the container, whether it's a WordPress or some other container I could create, but this is where I'll be providing all this. So once I create this, I'll be able to see in my option the task which I can use and provide a service name if I do test service. And this is where I would be having multiple options. What is the replica strategy I could use? And then how many tasks the cluster should it? This is where auto-scaling will also come into picture. The deployment options, whether it's a rolling or blue ring. And then what is the minimum and maximum percentages that one needs to ensure for monitoring purposes. Now, this is where these are the advanced concepts, something that we can go into. This is part of the service discovery, the service mesh scenario, something for more advanced topics. And this is where you see this is the VPC. It has used the default VPC. It creates the subnet. And ideally, you'd want to have this turned off because you wouldn't want the cluster sitting in a public subnet and then the application is able to connect to it. But rather, you would want the cluster fronted by a load balancer, which would do, like, we'll have a public, like, internet facing or internal load balancer, you could have it, but definitely not a public IP, because public IP, first of all, is going to be very expensive, and secondly, it's going to make your cluster insecure if you expose it directly. So definitely you would want to have a load balancer fronted with a WAF, and that's what we recommend to all our customers. But this is how you would go about creating a service. And if I see now comparing it with the Kubernetes, now this is where we see we have a different terminology where we have a cluster, but what we have is we have pods and nodes. In here we have a service and we have tasks, but that is where we have a node, which is you have it as part of, it's analogous to a service, while a pod is analogous to a task. It's a task definition or a container, and node is also a container in Kubernetes. So that is the terminology difference that is used as part of the setup. But if I see here, I could see these are the nodes that are there. And then if namespaces are going to be similar. I could have these default namespaces, something that I just set it up to show. And then if I do the workloads, I could come here and the different pods that could be used as part of the setup. And in compute, right, I could have a node group that could be created. Actually, I'm sitting in Virginia. Let me go to Oregon because that's where I had created the cluster. This is the cluster I had created for this particular purpose. And so this is the different regions we could have the setup. This is the role that was created as part of the cluster. Just to quickly show you what it is, the permissions that it requires. And this is one of the permissions, right? So it requires the cluster policy, resource controller, but it requires the CloudWatch, as well as the EC2 permissions that are there. And now if we go here to the resources, we would see that this is the cluster here. And if I go to the nodes, or if I go to the compute section, I could see the group name here that is there. And then if I go here, I could see the different node on and the capacity of the VM and then the auto scaling. Now in ECS, what you do is you have The auto scaling, if you're using Fargate, it is kind of out of the box. If you do it as a VM, what you would need to do is you would need to, let me close this tab. But if you come to ECS and if you choose the capacity provider as Fargate, but if you choose it as, there was this option of, let me start here and show. Here you could have the option of EC2 as part of the setup. And you could always attach this to the capacity provider. But this is, now I have not spun up any EC2, but you could have this option. You could provide it as part of the setup. Similarly, in Kubernetes, you could also do that. But where you do auto-scaling as part of an EC2 instance, this is where, let me go here. And this is where we have auto-scaling groups. Now, this is a section where we will be creating auto-scaling groups that are set up as part of, we will be creating an auto-scaling group. A launch template is what we will be selecting. If I go here, I'll be providing all the value here. I'll provide the name, information, the tags. If any source template I need to refer, build out of that, I could do. Any base AMI I need to use, I could choose it. A few things, what is the instance type? If I don't want to choose, but ideally you would want to have it because you would want to ensure that you choose a certain configuration that best works for your application. So that is where you would want to choose. The subnet, you don't want to put it to tier. You are better off putting in the auto-scaling group. So something you're better off just leaving it. Storage volumes, in case you have to persist the data for a microservices architecture. Something that is not many applications have the use case for, but there could be scenarios where you want to persist. So something to look into. But which and advanced details, you may want to ensure that you do have these profiles created, and ideally we would want to have all this done by Terraform, a CloudFormation. But something, if you want to do it manually, you could always come in here. And then as part of the optimized instances, you could do capacity reservation and lot of options out here that one could do. Now this is where metadata, you would want to have this as enabled, alright, because what it does is that you provide a little more security features, as well as say metadata version you would want to choose as V2, so that again this is a lot more secure option compared to choosing the V2. As something is, let me know if you want to get a little more detail about these different things, and I can definitely walk you through. But the whole point is, if you're using EC2, you would have to create a launch template and then ensure that and create the required alarms that a particular instance goes above a certain threshold. It will be able to scale up to a certain max number of instances that you provide. So that is where, and now this is where you provide all this setting as part of the auto scaling group. And let me show you this setting here for Kubernetes. It's going to be similar. It's not going to be any different, but this is where you see it's an Oregon. It's going to be similar as part of because over here I have a VM and I choose the activity, and this is where I choose automatic scaling. I choose instance management. And this is where I have the other instances that I have set up as part of Kubernetes. You see, this is where I see the instances. And if I go here, I'll be able to see those instances that are running as part of this setup now. Right. So if I go here, I'll be able to see those instances that are running and have my cluster deployed over here. So this is where, right, there are certain distinctions. ECS is a lot more simpler compared to Kubernetes, but there's a lot better ecosystem for Kubernetes compared to ECS. And that's what we usually recommend to our customers, that, okay, just consider that aspect as well. It's not that how quickly you could get your application running. So that is where one needs to look into. So that I hope this provides you a good overview about ECS and EKS. Please like, subscribe, share the video. Please contact us for any of your cloud requirements or cloud consulting requirements. We have decades of experience in cloud, and we can definitely help your organization take the right step in cloud. With that, thank you, and see you in the next video.